Imagine you're standing on a burned-out planet just a half step to either side, and one side of your body is melted at 430 degrees while the other is frozen at 180 degrees, and that world is Mercury, the vast crime scene left behind by the sun. From that razor-thin boundary with one side hot enough to melt lead and the other colder than the eternal night of Antarctica, we begin to open the case file of a small yet anomalous world, a gigantic iron core that takes up almost the entire planet, a bizarre 3-2 spin-orbit resonance that makes a single day longer than a year, the scars of ancient magma oceans, extinct ghost volcanoes, and a catastrophic impact that once shattered the terrain on the opposite side of the planet. From there, we follow the invisible sodium blood trail stretching millions of kilometers through space. Witness Mercury's weak, skewed magnetic heart being bent under electron storms. Watch Messenger sacrifice itself by diving into the surface to confirm water ice in regions of eternal darkness, while BepiColombo quietly closes in to prepare for the most thorough interrogation in history. Mercury is no longer a nameless charred rock, but a silent witness and iron warning for lava worlds around distant stars, and at the same time a grim preview of the fate of the inner planets, when the sun swells into a red giant. We're about to embark on a journey into the furnace of the solar system to finally learn what really happened to this iron bullet tortured by the sun for 4.6 billion years, and why understanding it is also a way of looking ahead at Earth's own future. Transport yourself for a moment to the most hostile frontier in our cosmic neighbourhood. You are standing on the surface of Mercury, but this is not the static grey rock you might expect. You are positioned precisely on the Terminator line, the razor-thin twilight zone separating the blistering day from the freezing night. To your left, the sun dominates the sky, a terrifying colossus, 3 times larger than it appears from Earth. In this scorched, sun-blasted inferno, the temperature soars to a staggering 430 degrees Celsius. It is hot enough to melt lead, a furnace fueled by searing temperatures and deadly radiation. To your right, there is only darkness. The sun set weeks ago, and given the planet's slow rotation, it won't rise again for weeks more. Here the temperature plunges violently to minus 180 degrees Celsius. It is a realm of flash-frozen silence where the ground beneath your heavily insulated boots is rigid, rapidly radiating the day's accumulated heat out into the vacuum of space. Above you the sky offers no comfort. Without an atmosphere to scatter light, there is no blue haze, only a perfect suffocating blackness. The stars do not twinkle. They stare down, stark and brilliant, unwavering witnesses to the desolation below. This is a world of impossible extremes. Standing here, you're straddling the line between an incinerator and a cryochamber. The silence is absolute, broken only by the Geiger counter clicking furiously in your ear, warning you of the invisible onslaught of solar particles. This isn't just a planetary surface. It is a crime scene where the evidence of solar violence is etched into every crater and fissure. And we are here to investigate. For decades, Mercury has remained the cold case of planetary science. Everyone knows the name of the first planet, yet it is arguably the least explored of the terrestrial worlds. This isolation is not due to a lack of interest, but a matter of physics. To reach Mercury is to fight a gravitational war against the Sun itself. Any spacecraft launched toward the inner solar system naturally accelerates as it falls into the Sun's massive gravity well. To stop at Mercury rather than hurtling past it, or worse, falling into the star, a probe must shed an enormous amount of velocity. It is akin to swimming upstream against ferocious whitewater rapids. Because of this, reaching this tiny rock requires more energy than sending a mission to the outer edges of the solar system past Pluto. Consequently, the case file on Mercury has been thin. Only 2 detectives have ever successfully reached the scene, Mariner 10 in the 1970s, which merely conducted flybys, and NASA's Messenger, which finally achieved orbit in 2011. But the limited data they returned revealed something profound. Mercury is a silent witness to the solar system's violent youth. Its heavily cratered surface serves as a fossilized record, preserving 4.6 billion years of asteroid and comet bombardment that tectonic activity has long erased on Earth. Now a new investigator is on the way. The BepiColombo mission is currently navigating the treacherous journey, executing complex maneuvers to slow down enough to capture the culprit. It aims to unlock the secrets hidden in the planet's magnetic field and internal structure. Until it settles into orbit, Mercury remains a riddle wrapped in radiation, a silent, scarred observer waiting to tell its story. To the casual observer, the victim appears to be a twin of our own moon. It shares that same battered grey visage scarred by eons of cosmic bombardment. But this visual similarity is a deception. When we place Mercury on the cosmic scales, the forensic data reveals a heavy metal anomaly hiding in plain sight. The numbers from the autopsy are staggering. Mercury consists of approximately 70% metallic material and only 30% silicates. This ratio is bizarre for a terrestrial planet. It results in a density of 5.427 grams per cubic centimetre, the second highest in the solar system. It trails only slightly behind Earth, which sits at 5.515 g cm3. However, Earth's density is largely a result of its own mass compressing its interior. If Mercury were expanded to the size of Earth, its uncompressed density would be far higher, creating a crushing gravitational environment. This internal density creates a gravitational paradox. Despite being physically much smaller than Mars, and even smaller than giant moons like Ganymede and Titan, Mercury exerts a surface gravity of 3.7 mes2. This is almost identical to the gravity found on the red planet. A traveller standing on Mercury would feel a pull disproportionate to the tiny world beneath their feet. Essentially, Mercury is not a standard planet. It is a cosmic cannonball. It is a massive iron core wrapped in a vanishingly thin veneer of rock. This structure is so unusual that it challenges our standard models of planetary formation. It suggests that the Mercury we see today is merely the remnant of something much larger, a planetary core that has survived while its outer layers were stripped away. The question is, what kind of violence could peel the skin off an entire planet? This anomalous density points to a crime of subtraction on a planetary scale. In forensic terms, Mercury is a differentiated body that has been flayed. The standard model of planetary formation cannot account for a world that is essentially all core and no mantle. The forensic evidence suggests that the Mercury we see today is merely the survivor of a much larger planetary embryo that suffered a catastrophic trauma in the early solar system. The leading theory is a cosmic hit and run. We suspect that billions of years ago, a protoplanet perhaps the size of Earth slammed into young Mercury. This wasn't a merger, it was a grazing blow, a violent collision that shattered the planet's lighter silicate crust and mantle, blasting them out into space where they were eventually swallowed by the sun or swept away. What remained was the heavy iron-rich core, scarred and stripped naked, condensing into the smaller, denser world we investigate today. However, the case is not so simple. When the messenger probe analysed the chemical composition of the surface, it found high levels of volatile elements like potassium, sulfur and chlorine. These elements vaporize easily at high temperatures. If the hit-and-run collision had been an incinerating event, these volatiles should have boiled off into the void. Their presence is a baffling clue that complicates the timeline, effectively disproving many previous theories about how this solar system formed. We are left with a paradox, a planet that looks physically stripped by violence, yet chemically retains the fingerprints of a colder formation. It is a battered survivor hiding its origins behind a facade of iron and rock. And as we dig deeper into its behaviour, we find that not only is its body deformed, but its relationship with time itself is distorted. The victim does not just suffer from physical deformities, its relationship with time itself is fractured. For decades, investigators believed Mercury was tidally locked to the sun, forced to forever show the same face to its star, much like the moon does to Earth. This was a reasonable assumption, as every time astronomers looked during prime observation windows, Mercury appeared frozen in the same position. However, radar interrogation of the planet later revealed that this was merely a coincidence of timing. The reality is far more disorienting. Mercury is trapped in a unique 3-2 spin orbit resonance. It spins on its axis exactly 3 times for every 2 revolutions it completes around the Sun. This resonance creates a temporal distortion, where a day on Mercury is longer than a year. While it takes 88 Earth days to orbit the Sun, it takes a staggering 176 Earth days for the Sun to return to the same place in the sky, a solar day that lasts 2 full Mercurian years. If you were standing on the surface, this distortion would manifest as a vertigo-inducing celestial dance. As the planet rushes toward perihelion, its closest approach to the star, its orbital speed accelerates drastically. For a brief window, the planet physically travels around the Sun faster than it spins on its axis. The result is a visual impossibility. The Sun, dragging its massive glare across the black sky, slows down, stops completely, and then begins to move backwards. This retrograde motion lasts for several Earth days before the Sun pauses again and resumes its normal path toward the horizon. On this world, the Sun does not just rise and set, it hesitates, mocking the laws of motion we are used to. It is a dizzying reminder that here gravity dictates not just the orbit but the very flow of the day itself. To understand the victim's current disfigurement, we must rewind the clock to a time when the planet was liquefying. Mercury's geological record reveals an era where the rock itself surrendered to heat, breaking down into magma with a viscosity similar to ketchup. The most damning forensic evidence for this melting era is found in the Raditladi Basin. Raditladi is a relatively young wound estimated to be under 1 billion years old. To an investigator's eye, its structure contains a glaring anomaly. The surrounding walls are rugged and jagged, yet the crater floor is unnaturally smooth. In the natural world, only liquids settle into such perfectly flat surfaces. This indicates that immediately following the impact, the basin filled with lava. The debate continues over the source of this fluid. Was it impact melt, the crust, instantaneous liquefying under the kinetic energy of the collision, or did the blow puncture the crust, triggering a creeping volcanic eruption from the deep? Likely it was a combination of both. But the bleeding did not stop at craters. We find the scars of ancient movement in the valley known as Ancora Vallis. Here the lava did not just pool, it travelled. The fluid rock flowed like a river from high ground to low carving channels, before pouring into vast basins to form magma seas. These ancient flows covered vast swathes of the planet, staining the surface in a distinctive orange hue that scientists now recognize as the telltale signature of volcanic activity. This was a world where the ground was not a solid foundation, but a moving, burning ocean. The forensic trail leads us next to a specific chromatic anomaly. When investigators enhanced the colour saturation of the surface images, they discovered vast swathes of the planet stained in a distinct rusty orange hue. In planetary forensics, this colour is the telltale signature of explosive volcanic activity. It suggests that the victim didn't just bleed lava, it violently purged it. The smoking gun for this explosive past is found at the Navoi crater. To the untrained eye, it looks like just another impact scar. But a ballistics analysis reveals a crucial discrepancy. When a meteor strikes a hard surface, the rebound force typically creates a central peak, a mountain of debris pushed upward in the centre of the bowl. Navoi has no such peak. Its ray system is irregular, neither rounded nor teardrop-shaped like a standard impact. The conclusion is chilling. Navoi was not formed by a blow from above, but by a detonation from below. It is a volcanic vent 66 kilometers wide, carved out by an eruption of unimaginable force. The pressure required to scoop out a crater of this magnitude and scatter its remnants for kilometers suggests a cataclysmic event. This wasn't a slow oozing flow, it was a pyroclastic assault. When the messenger probe flew over the northeast of the Rachmaninoff Basin, it detected a blanket of fine dust coating the terrain. This was volcanic ash blasted out of vents at supersonic speeds. NASA scientists described the fallout as fiery, angry snow. Imagine standing there as the sky turned black, choking on toxic fumes, while millions of tons of burning ash rained down, burying the landscape. These ghost volcanoes are silent now, but their ash remains a preserved layer of evidence pointing to a time when the planet tried to turn itself inside out. If the volcanoes were the victim purging itself from within, the next piece of evidence represents an assault from without, a blunt force trauma so severe it nearly shattered the planet. Investigators call it the Caloris Basin. Spanning a colossal 550 kilometers in diameter, Caloris is one of the widest impact craters in the entire solar system. The timeline places this assault approximately 3.9 billion years ago, likely caused by a massive comet or asteroid collision. This was not a simple puncture, it was a skull fracture. The kinetic energy delivered was so intense that it liquefied the crust, causing massive lava eruptions that flooded the basin floor and pushed up a concentric ring of mountains over 2 kilometers high surrounding the impact site. But the true extent of the violence is found not at the impact site, but on the exact opposite side of the planet. At the antipode of the Caloris Basin lies a region of chaotic, jumbled geography, appropriately named the Weird Terrain. For years, this hilly, broken landscape was a puzzle. Now ballistics models reveal the cause. The shockwaves from the Caloris impact did not dissipate. They travelled through the planet's iron heart, focusing like a lens. They raced around the globe and converged at a single point on the far side. The ground at the antipode was lifted and shattered by the converging seismic waves, creating a geological exit wound, without a projectile ever breaking the skin. The planet shuddered so violently that the surface itself broke apart. This evidence confirms that Mercury is not just cratered. It is a body that has survived a beating that would have obliterated a lesser world. For thousands of years, astronomers believed the victim was contained a simple solid rock orbiting in a vacuum. But in 2001, investigators at the McDonald Observatory in Texas switched on a specialized forensic filter and revealed a shocking truth: Mercury is hemorrhaging. What they saw was initially dismissed as an equipment malfunction or a data processing error. It seemed impossible. Trailing behind this tiny airless world was a colossal ghostly structure, a tail stretching almost 2.5 million kilometers into the blackness. To put that scale into perspective, the blood trail is 700 times the width of the planet itself. Mercury was not just a planet, it was mimicking a comet dragging a spectral veil through the solar system. The substance leaking into space is sodium. Under the intense glare of the sun, sodium atoms become excited and emit photons at a very specific wavelength, 589 nanometers. This is the distinct yellow-orange hue of old streetlights. However, to the naked human eye and standard telescopes, this trail is completely invisible. To reveal it, astronomers must use sodium D-line filters, which block out all other wavelengths of light and isolate only the faint 589 nanometer glow. In our forensic investigation, this filter acts exactly like luminol at a crime scene. Just as luminol makes invisible bloodstains glow blue in a dark room, these filters force the invisible sodium tail to shine against the backdrop of space. The victim is bleeding out into the void, leaving a glowing DNA trail that points directly to the perpetrator. The culprit behind this hemorrhage is the sun itself, acting not as a life-giver, but as a relentless assailant. At perihelion, Mercury approaches within 47 million kilometers of the star, entering a kill zone, where solar radiation is 10 times more intense than what we experience on Earth. Here, the planet is subjected to a violent process known as sputtering. Imagine the solar wind as a constant torrential stream of charged particles firing at 1.6 million kilometers per hour. Without a thick atmosphere to act as a shield, these ions slam directly into Mercury's surface with kinetic fury. The impact is a ballistic event at the atomic level. The energy transfers instantly to the surface rocks, violently knocking loose the weakest atoms, specifically sodium, and launching them high into the exosphere. It is a continuous high-energy erosion, stripping the planet of its surface material atom by atom. But the Sun has an accomplice: micrometeoroids. In this dust-rich region of the inner solar system, tiny space rocks constantly pelt the planet. Because there is no air to burn them up, they strike with full force, vaporizing surface rock upon impact, and injecting even more sodium vapor into the sky. We are essentially witnessing a planet slowly disintegrating under a crossfire of particle bombardment. Once these atoms are airborne, a second force takes over to dispose of the evident solar radiation pressure. Light itself carries momentum. When a sodium atom absorbs a photon from the sun, it receives a tiny physical shove away from the star. This happens repeatedly, acting like a constant wind pushing against a sail. This relentless pressure overcomes Mercury's weak gravity, accelerating the sodium atoms away from the sun and stretching them out into the vast comet-like tail we observe from Earth. The forensic timeline reveals that this hemorrhage is not a steady flow. It pulses with a distinct seasonal rhythm. Logic would suggest that the sodium tail should be brightest at perihelion, the point in Mercury's 88-day orbit where it is closest to the Sun and the solar wind is most ferocious. However, the evidence contradicts this. The blood trail does not reach its peak visibility when the heat is highest. Instead, it flares up exactly 16 days later. This delay was a baffling anomaly until investigators applied the laws of physics to the planet's velocity. Mercury's orbit is highly elliptical, causing its speed to fluctuate wildly. It reaches its maximum radial velocity, its top speed moving away from the Sun, precisely 16 days after perihelion. This speed is the key trigger for a phenomenon known as the Doppler shift. Under normal conditions, the Sun acts as a sensor. The solar atmosphere contains sodium, which absorbs the very specific 589 nanometer light that Mercury's tail needs to glow. These dark gaps in the solar spectrum are called Fraunhofer absorption lines. Essentially, the Sun blocks the energy required to illuminate the evidence. But when Mercury accelerates away from the star, the sunlight hitting it is stretched or red-shifted due to the Doppler effect. This shift moves the incoming sunlight just outside the sun's sodium absorption lines. Suddenly the sensor is bypassed. The sodium atoms in the tail are flooded with unblocked light, absorbing it and scattering it back toward Earth. It is only when the victim is running away at top speed that the full extent of its injury becomes visible to our detectors. The most chilling finding in our geological autopsy is that the victim is not static. It is actively crushing itself. As the planet's massive iron core slowly loses the primordial heat of its formation, it cools and solidifies. In a human body, death brings rigor mortis, a stiffening of the muscles. On Mercury, this cooling process triggers a terrifying global contraction. As the interior volume shrinks, the solid outer crust becomes too large for the body inside. With nowhere to go, the rock buckles, breaks and thrusts upward over itself. The surface is littered with the scars of this self-destruction, known geologically as lopsided scarps. The most prominent incision on the body is Beagle Roops, first imaged by the Messenger probe in 2008. This is not a canyon carved by water or wind, but a massive thrust fault stretching 600 kilometers across the planet's skin. It possesses a pronounced curvature, a jagged ridge formed where one tectonic plate has been forced violently over another. This is not a localized injury, it is systemic failure. Other than our moon, Mercury is the only planetary body in our solar system known to exhibit this specific tectonic signature. By mapping these wrinkles, Messenger's data revealed a staggering statistic since its formation. Mercury's diameter has contracted by over 14 kilometers. Imagine the sound of an entire world groaning as it shrinks, its surface crumpling like the skin of a drying apple. The Beagle Roops is a 600-kilometer-long scar tissue, a permanent record of the moment the planet's crust snapped under the pressure of its own dying heart. If the crust exhibits the rigor mortis of a corpse, the interior provides a conflicting, almost impossible testimony. Deep inside the victim, a heart is still beating, but the rhythm is all wrong. One of the foundational rules of planetary forensics is that small, slow-rotating worlds do not generate magnetic fields. Mars is dead. Venus is silent. A planetary dynamo, the engine that generates a magnetosphere, typically requires a liquid metal core churning rapidly driven by the planet's spin. Mercury rotates painfully slowly, completing just one turn every 59 Earth days. By all laws of stellar physics, its internal engine should have seized up and gone cold billions of years ago. Yet the sensors tell a different story. Mercury possesses a global magnetic field, making it the only terrestrial planet in the solar system, other than Earth, to exhibit this sign of life. However, this heartbeat is incredibly faint, registering at just 1.1% the strength of Earth's magnetic field. It is a weak, struggling pulse maintained likely by the immense tidal squeezing of the sun, keeping the core molten against the odds. But the most suspicious detail is the alignment. The magnetic field is fundamentally broken. Unlike Earth, where the magnetic poles align roughly with the geographic center, Mercury's magnetic equator is displaced. The entire field is offset by approximately 480 kilometers, about 20% of the planet's radius toward the North Pole. This arrhythmic lopsidedness has catastrophic consequences for the planet's defense. Because the shield is pushed north, the southern hemisphere is left with a gaping vulnerability. In the south, the magnetic field lines are so weak that the solar wind can hammer the surface with impunity, creating a localized zone of intense radiation and weathering. It is a compromised defense system that barely qualifies as a shield at all. Because the victim's magnetic shield is so weak and heavily offset, it buckles under pressure. The solar wind does not just buffet the planet, it frequently smashes through the defenses in violent episodes known as magnetic reconnection events. These occur when the magnetic field lines of the incoming solar wind press too hard against Mercury's own field, snapping together and physically breaking the shield open. On Earth, such events are relatively rare, and usually result in the beautiful harmless dancing lights of the aurora. On Mercury, they are a frequent violent assault. Data from the Messenger probe indicates that reconnection events occur here 100 times more often than they do around Earth. When the field lines snap, they create a momentary hole in the defense, a funnel through which high-energy solar plasma pours directly into the planet's atmosphereless environment. This breach triggers what investigators call electron storms. Messenger detected sudden energetic bursts of electrons producing hundreds of thousands of electron volts of energy. These are not gentle showers, they are invisible radioactive downpours. The forensic mapping of these storms reveals a disturbing pattern. They are highly localized. The electron bursts are concentrated heavily in the northern hemisphere and are compressed tightly against the planet along the sun-facing side. The mechanism appears to be a breakdown in the planet's magnetotail, the long magnetic shadow trailing behind the planet. Electrons are accelerated through these snaps in the field and channeled along magnetic highways directly onto the surface. For any observer standing on the northern plains, there would be no warning. One moment's silence. The next, a lethal dose of high-voltage radiation raining down from a clear black sky, chemically altering the very ground beneath their feet. The first detective to successfully stake out the crime scene for an extended period was NASA's Messenger. But to gather its evidence, this probe had to become a suicide runner. Launched in 2004, it spent 6.5 years navigating the inner solar system before finally entering Mercury's orbit in 2011. To survive the thermal kill zone, Messenger adopted a desperate strategy. It utilized a ceramic heat shield to deflect the sun's glare, which is 7 times brighter at Mercury than at Earth. Crucially, it maintained a highly elliptical orbit swinging from a close approach of 200 kilometers out to 15,000 kilometers every 12 hours. This maneuver was a necessity. It allowed the spacecraft to retreat from the planet's radiating heat and cool off before diving back into the fire for another pass. Before its mission ended, Messenger transmitted a piece of evidence that seemed physically impossible: water ice. The probe confirmed earlier radar suspicions that the North Pole harbours vast deposits of frozen water. These deposits are hidden at the bottom of permanently shadowed craters, regions of eternal darkness where sunlight never reaches. In these deadly oases, temperatures remain low enough for an estimated quadrillion kilograms of ice to survive mere miles from surface temperatures hot enough to melt lead. The investigation ended violently on April 30, 2015. Having exhausted its propellant after 4 years of orbital maneuvers, the probe could no longer fight the planet's gravity. Orbiting a mere 25 kilometers from the surface in its final days, Messenger slammed into the planet, excavating a new crater and becoming a permanent part of the world it was sent to study. It gave its life to build the file, but it left many questions unanswered. With Messenger gone, the crime scene sat undisturbed for years. But now, a new, heavier-hitting investigator is en route to conduct the most comprehensive interrogation in history. Named BepiColombo, this mission is a joint operation between the European Space Agency and the Japanese Aerospace Exploration Agency. Launched in October 2018, it is currently executing a 7-year stakeout through the inner solar system. To the uninitiated, the flight path seems absurd. To reach a neighbour that is relatively close, BepiColombo must travel a staggering 8.5 billion kilometres, a distance greater than a trip to Pluto. This circuitous route is dictated by the merciless laws of orbital mechanics. Falling toward the Sun provides an immense gravitational acceleration. If the spacecraft simply flew straight at Mercury, it would arrive with such tremendous velocity that it would overshoot the planet entirely and be swallowed by the Sun's gravitational field. Therefore, the mission is not a sprint. It is a massive 7-year braking maneuver. To shed enough energy to be captured by Mercury's weak gravity, BepiColombo must perform a complex ballet of 9 planetary flybys, 1 of Earth, 2 of Venus, and 6 of Mercury itself. These are gravity assist maneuvers used in reverse robbing the spacecraft of momentum to slow it down. Assisting in this deceleration are solar electric propulsion thrusters, which fire in prolonged arcs lasting months at a time, fighting against the Sun's pull. The spacecraft itself is a stack of 3 components travelling together, a transfer module carrying 2 distinct probes. Once the stack finally inserts into orbit in December 2025, it will separate, deploying Europe's MPO to scan the surface and Japan's MEO to hunt the magnetic ghost. The long cruise is nearly over. The real questioning is about to begin. We often say that space is silent, a vacuum where sound cannot travel, but for a forensic investigator equipped with the right sensors, the crime scene is deafening. BepiColombo didn't just photograph the victim, it listened to it. During its flyby, the spacecraft carried an accelerometer similar to the one in your smartphone that detects orientation, mounted on its structure to measure minute vibrations. As the probe drifted past Mercury, it physically shuddered. It captured the sound of the spacecraft reacting to the sudden drop in solar radiation pressure as it slipped into the planet's shadow, followed by the mechanical clunk of instruments shifting into parking positions. But the most haunting testimony came from the invisible magnetic field. Scientists on Earth took the raw magnetometer data and sonified it, mapping the intensity of the magnetic forces to audible frequencies we can hear. The result is a soundtrack of magnetic violence. In this audio translation, the pitch changes with the intensity of the background magnetic field. As BepiColombo swept past the planet, the audio remained relatively stable until it hit the boundary line. Suddenly the sound erupts into a chaotic rhythmic abrasion. Scientists have likened this specific noise to a DJ scratching a disc, a series of fast, sharp changes in pitch. This scratching is not static interference. It marks the exact moment the spacecraft crossed the magnetosheath, the highly turbulent border region, where Mercury's weak magnetic field collides head-on with the torrential solar wind. What you're hearing is the physical signature of the struggle between the planet and the star. It is the visceral, chaotic scream of a shield buckling under an endless assault. Despite the mountains of evidence collected by our mechanical detectives, the file on Mercury remains frustratingly incomplete. As we scan the surface, we find anomalies that defy the standard profile of a dead airless world. The victim is hiding secrets. The most baffling of these are the hollows. When Messenger sent back high-resolution images, investigators found strange irregular depressions scattered across the planet. These are not impact craters. They are rimless shallow pits often surrounded by bright, fresh halos. In forensic terms, they look like rot. They suggest that some form of volatile material, perhaps sulfur or carbon, is currently sublimating, turning directly from solid to gas, and leaving void spaces behind. This shouldn't be happening on a former billion-year-old rock that was supposedly baked dry eons ago. The existence of hollows implies that Mercury is still geologically active, evaporating from the inside out. Then there is the Spider, officially known as the Pantheon Fossae. Located near the centre of the Caloris Basin, this formation consists of hundreds of troughs radiating outward from a central point stretching for huge distances. It resembles a pane of glass that has been smashed by a hammer. This shattering pattern is unique. Mercury's crust typically handles impacts like sand, not brittle glass. At the centre of this web sits the Apollodorus crater. A rookie investigator might assume the impact caused the cracks. But a precise ballistic analysis reveals a discrepancy. The crater is not perfectly aligned with the epicenter of the fractures. This suggests the Spider might not be an external injury, but an internal intrusion, a massive upwelling of magma that pushed the crust upward until it cracked only for a meteor to strike the site later by sheer cosmic coincidence. Is it a wound from above or a breakout from below? We still don't know. As we close this preliminary file, the verdict on Mercury has shifted dramatically. For centuries we dismissed the first planet as a boring, scorched rock, the runt of the litter. But the forensic evidence collected by our mechanical detectives proves otherwise. Mercury is not just a victim, it is the ultimate survivor. This battered world with its oversized iron heart and shrinking skin serves as a Rosetta Stone for the violent history of our cosmic neighborhood. It holds the baseline data for planetary evolution under the most extreme conditions. By studying how Mercury bleeds sodium into space, we gain crucial insights into how stars erode the atmospheres of planets across the galaxy. It acts as a local proxy for the hot Jupiters and lava worlds we are discovering around distant stars. Mercury is the charred remains of the solar system's chaotic youth. It has endured 6 billion years of solar radiation, asteroid bombardment, and gravitational torture. It stands as a testament to resilience, holding its ground in the furnace while carrying the scars of a history that Earth has long since erased. The investigation is far from over. When BepiColombo arrives in December 2025, it will not just be visiting a planet, it will be stepping into a laboratory of extremes. Until then, Mercury remains the solar system's silent witness, a rusted key waiting to unlock the secrets of where we came from, and perhaps the fiery fate that awaits us all. As we finally close the case file on Mercury, a staggering truth begins to emerge. We began this journey expecting to perform an autopsy on a planetary corpse, a dry dead rock baked by the sun and forgotten by time. But the forensic evidence we have gathered from the glowing blood trail of the sodium tail stretching millions of kilometers to the wrinkled scarps of a shrinking crust and the faint pulse of an arrhythmic magnetic heart tells a radically different story. Mercury is not a passive victim. It is the solar system's greatest survivor. Consider the violence this iron bullet has endured. Born directly adjacent to a massive nuclear furnace, it likely suffered a catastrophic hit and run in the early solar system that stripped away its outer layers, leaving its core exposed. It has weathered 4.6 billion years of solar wind bombardment, stripping it atom by atom. It is crushed by immense gravitational tides and roasted by temperatures hot enough to melt lead. Any lesser world would have been pulverized, swallowed by the star, or blown into the deep void. Yet Mercury remains. It still spins, however slowly. Its heart still beats, however faintly. The true value of Mercury does not lie in its resources or its potential for colonization, but in its role as the silent witness. Because our dynamic Earth constantly erases its own memory through wind, water, and plate tectonics, we have lost the opening chapters of our history. But Mercury does not forget. On its scarred, pockmarked surface lies a perfectly preserved record of the solar system's most chaotic era. It holds the baseline data for how a planet forms, how it dies, and how it interacts with its host star. The investigation is far from closed. The Messenger mission ended its watch by sacrificing itself, crashing into the surface to send back one final stream of data. And even as we speak, the next detective, BepiColombo, is drifting through the dark, carrying humanity's most sensitive instruments to listen to the scream of the magnetosphere and peer into the planet's core. When it fully inserts into orbit in December 2025, we will not just see Mercury more clearly, we will understand ourselves better. Ultimately, to understand Mercury is to understand the most extreme scenario of existence. It reminds us that the universe was not designed for life. It was designed for chaos. The fact that this tiny, lonely planet continues to cling to the edge of the solar inferno is nothing short of a miracle of physics. Mercury remains there, twinkling in Earth's twilight, an iron bullet a crime scene, and a rusted key waiting to unlock the mysterious past of us all. The investigation has only just begun. If Mercury is a crime scene, it is also a warning. As we step back from the microscope, we realise that the forensic data collected from this battered world has applications far beyond our own solar neighbourhood. Mercury is not just a local anomaly, it is the galactic baseline for a terrifying class of planets we're only just beginning to discover. In the last 2 decades, our space telescopes have identified thousands of exoplanets orbiting distant stars. Among them is a common hellish archetype known as lava worlds, or super-Mercuries. These are rocky planets orbiting so close to their host stars that their years last only hours and their surfaces are perpetually molten. Until recently, we could only guess at the physics governing these alien infernos. But thanks to our investigation of Mercury, we now have a working model. The blood trail of sodium we discovered leaking from Mercury is now being used as a template to hunt for atmospheres on these distant worlds. By looking for similar spectral signatures of atmospheric stripping around other stars, astronomers can determine which exoplanets are dead rocks, and which might still hold on to the shielding necessary for life. Mercury has taught us that the line between a habitable world and a stripped core is drawn by the magnetic field. It has shown us that a planet without a strong heartbeat is defenseless against the hunger of its star. Furthermore, Mercury offers a grim prophecy for the future of the solar system itself. We know that our sun is not static. It is slowly brightening and expanding as it ages. In approximately 5 billion years, it will exhaust its hydrogen fuel and swell into a red giant. Mercury will be the first casualty of this stellar death throes. Current models suggest that as the Sun expands, its atmosphere will engulf Mercury entirely. The planet will spiral inward, experiencing a reversal of its birth, its rock vaporizing its iron core, dissolving into the plasma of the dying star. In studying Mercury today, its composition, its resistance to heat, its orbital decay, we are essentially writing the obituary for the inner solar system. We are observing the early stages of the mechanism that will eventually claim Venus and likely Earth. This is why the BepiColombo mission is critical. By understanding the precise interaction between the solar wind and Mercury's magnetic field, we are learning how to predict space weather that affects us here on Earth. We are learning how long a rocky planet can survive in the kill zone. In the end, the file on Mercury is a story of contrast. It sits there a scarred, shrinking, radiation-blasted testament to what happens when a planet loses the lottery of cosmic location. It is the failed Earth, the sibling that took the brunt of the sun's fury so that we could exist in the temperate safety of the Goldilocks zone. It is a reminder that our existence is fragile, protected by a magnetic shield that we must never take for granted. The iron bullet spins on keeping its secrets in the dark, waiting for the day it returns to the fire from which it came. Finally, beyond the geology and the magnetic storms, there remains one piece of evidence that transcends the planet entirely: the distortion of reality itself. Long before we spotted the sodium tail or the shrinking crust, Mercury provided the smoking gun for Albert Einstein's theory of general relativity. Its orbit wobbling in a specific way that Newtonian physics could not explain proved that the Sun's immense mass was physically warping the fabric of space-time around the planet. BepiColombo returns to this gravitational crime scene not just to map rock, but to test the fundamental laws of the universe. By measuring Mercury's motion with atomic clock precision, the mission will stress test Einstein's equations in the most extreme laboratory available. This iron world does not just occupy space, it bends it. It serves as the ultimate reminder that in the grand investigation of the cosmos, the smallest clues often reveal the vastest truths. Mercury sits at the edge of the abyss, a heavy metal anchor, holding the secrets of gravity itself, daring us to question everything we think we know about the nature of reality.